Clear? So until now we have studied refraction through different media. For example, if this is one medium and if this is second medium, are you able to understand? Then when light enters from one medium to another medium, then what is happening that we have studied. For example, if this is glass and if this is water, water is less denser when compared to glass, no? So light bends away from the normal. Okay, this is what we have studied. Now what happens when light enters into curved refracting surfaces? So how many types of curved refracting surfaces are there? One is convex curved surface, curved refracting surface, clear now? And second one is concave curved refracting surface. So two kinds of surfaces are present. For example, if I take about a convex surface, then this is an example of a convex surface. Are you able to understand? So consider there is a piece of glass. Consider this total is a glass whose refractive index is mu2, and it is a denser medium, denser medium whose refractive index is mu2. So therefore, this is the principal axis which is passing through the pole of this what you call convex surface. This is a convex surface. So this total is made up of a glass. Are you able to understand? Now for example, what will be the radius of curvature of this one? See, this curved surface, this also will be a part of sphere only. Okay. So if I complete this one in the form of a circle, then this is how I can complete the circle. Then what is the center of the circle? Center of the circle will be somewhere here. Okay. So therefore this distance we can call it as radius of curvature. So the distance between pole and center of curvature is called as R, radius of curvature. So this is also, it should have been made from a sphere only, so spherical surface. Okay. Now consider here there is an object which is present. So this is the object. Clear? Then from the center of curvature, let us draw one normal. Then this becomes the normal, for example. Are you able to understand me? So if you draw a straight line from the center of curvature, that straight line itself will become the normal. So this is the normal. Okay. Now light from this object, it goes and falls here. Are you able to understand me? Light from this object, it goes and touches this refracting surface here. Now this is air, which is a rarer medium, and this is glass, which is a denser medium. Now when light falls here, now can you say what will happen? Will the speed of the light increase or will the speed of the light decrease? See, actually light should travel in this direction. Light should travel in this direction. Okay. But because there is a refracting surface, now what happens to the speed of light? Speed of light decreases. Why speed of light is decreasing, Subara? Because light is entering from rarer to denser medium, so definitely speed of the light decreases. If speed of the light decreases, why speed of the light is decreasing? Because wavelength is reducing. Frequency is not changing. Already we discussed yesterday, frequency never changes. Wavelength of the light reduces. Now, will it bend towards the normal or away from the normal? It will bend towards the normal, no? So therefore, what will happen? So, instead of moving like this light ray starts bending towards the normal. So, it will travel somewhat like this. It is bending towards the normal only, no? Actually, light should travel like this, but it is bending towards the normal. So, this is what will happen. Are you able to understand now? So, therefore, okay. So, light will continue to travel like this. But light rays from this object, they never meet with each other. Okay. For example, if you draw one more light ray here, it also moves away from the normal. And this light ray and this light ray, they are never going to meet with each other. It means real image cannot be created in this condition. Okay. So, therefore, what you do is, you extend this light ray backwards. Okay, ma'am? If I extend this light ray backwards, then here a virtual image will be created. That's what I can say. If real light rays, if they don't meet with each other, then real image cannot be created. Okay. For example, from here if you draw one more normal, this is second normal. Okay. So light rays from this object, it is reaching to this point. Okay. Now again it is entering from rarer to denser medium, again it should bend away towards the north. So actually light should travel in this path if there is no glass, but because there is glass, light will travel in this direction. Are you able to understand? So this light ray and this light ray, are they meeting with each other? They are not at all meeting with each other. Are you able to understand? So real image cannot be created, only virtual images can be created. Okay. So therefore, if I extend this light ray backwards, then I see that a virtual image is created somewhere here. Are you able to understand how image creation we are doing? So everywhere we are applying Snell's law. Sin I divided by sin r is equals to mu2 divided by mu1. So rarer medium always we are representing by mu1. Denser medium always we are representing by mu2. Are you able to understand? Then for any type of refracting surface, whether it is a convex refracting surface or a concave refracting surface. Concave refracting surface will be how? So concave refracting surface will be somewhat like this. Okay, ma? So this is a piece of glass, but what is the shape of the glass? Concave. So this type of refracting glass we can call it as concave refracting surface. And here a pole of this object will be present and this will become the principal axis. Are you able to understand? So here also let us draw some image. Okay. So consider which is the center of curvature of this one. This will become the center of curvature number. Approximately I can say this is the center of curvature. Okay. Center of curvature. So for example, if object is present here. Okay, what is this one? This is the object which is present and this is the center of curvature. So how can I draw the normal? From the center of curvature, if you draw a straight line to the mirror, that will become the normal. That's all. No? Okay. Now if I write one light ray passing somewhere up to here. Okay, then now light is again entering from rarer medium to denser medium. So actually light should travel in this path. No? If there is no refracting surface, light should travel in this direction. But what it will do, it will bend towards the normal. Are you able to understand? This is the normal, no? This line is the normal. So it will bend towards the normal. So therefore, if you extend this one backwards, image is created somewhere here. Are you able to understand? And here also what kind of image is created? This is also a virtual image. So real image may be created, virtual image also may be created depending on the position of the object. Are you able to understand? So therefore, for any kind of refracting surface, whether it is convex or whether it is concave, whether a real image is created or whether a virtual image is created. Are you able to understand? So cases we write here. Shall we write the cases? Completed now this one. First make a note of these diagrams. This is also a convex refracting surface only, no? Convex refracting surface. Now let us consider object is at a very long distance. So consider object is somewhere here. Okay. So this is the position of the object. Okay. So it means when compared to the radius of curvature, object is present at a very long distance. Now from here, if I draw a light ray here, are you able to understand? Then actually it should travel in this path, no? Actually it should travel like this. Original path. But because it is entering from rarer medium to denser medium, so it will bend towards the normal. Okay. So similarly from here, if I draw one more light ray, it will come and meet here. So therefore, here the image will be created. And this is what kind of image? This is a real image. And this is what kind of refracting surface? Convex refracting surface. So same type of diagram you can draw in concave also. Are you able to understand? So therefore, what I understand, so note points are that real images and virtual images both can be created. Both can be created. Are you able to understand? So with the help of refracting surfaces, you can create real images also, you can create virtual images also. That's what we have understood now. So everything depends on what? Everything depends upon the position of the object, where the object is present. Okay. So therefore what I write, so we write one case. And one more point is that, okay ma? So rarer medium is always taken mu1. Okay ma? Rarer medium is always taken as mu1. And denser medium is always taken as mu2. That is understandable, no? And vice versa. It means denser medium is always taken as mu2. sign conventions must be used. Sign conventions must be used. You must use the sign conventions. Are you able to understand? Now I will write one case. Case is that, okay, case number 1. So case number 1 is if object is in a rarer medium. If object is present in a rarer medium. Are you able to understand? So if object is present in rarer medium, okay, then the equation is mu2 by v minus mu1 divided by u is equals to mu2 minus mu1 divided by r. This is my equation. Okay. Okay, this is the equation to leave. That you should not forget. And mu2 is the refractive index of denser medium only. And what is v? V is the image distance. Image distance from where you have to measure? You have to measure from pole itself. This is the pole of this refracting surface. No? So therefore, this distance we can call it as v. Okay. Now in this condition, is it a plus v or minus v? Plus v. Why plus v? Because from the object, light is traveling in this direction. No? Light is traveling in this direction. We are also traveling in the same direction. So object distance is positive. So that's what we have written. No? Sign conventions must be used. You have to use sign conventions in this condition also. Okay. Next, what is u? U means object distance. And object distance is this distance. Again, every measurement I have to make from pole only. So this distance is called as object distance. So plus u or minus u? Minus u. Why minus u? Because light is traveling in one direction, but we are traveling in opposite direction. And which is the radius of curvature? This distance is nothing but radius of curvature. Are you able to understand? Distance between pole and radius of curvature, center of curvature is called radius of curvature. Now in this condition, radius of curvature, is it positive or negative? Positive. Why positive? Because light is traveling in this direction, we are also traveling in the same direction. Understood, Nama? That's it. So everywhere you have to use the sign conventions according to the requirement of the problem. Fine. Next, case number 2. Okay. Case number 2 is if object is in denser medium. If object is in denser medium. Are you able to understand? See, here object is present in rarer medium. No? Object may be present inside this refracting surface also. Object can be present in refracting surface also. Are you able to understand? In that condition, what you are supposed to do, just interchange mu1 and mu2 values, that's all. Okay? Interchange mu1 and mu2 values means mu1 divided by v minus mu2 divided by u is equals to mu1 minus mu2 divided by r. So this is the equation. Okay? So this is for which condition? When object is present in denser medium. Okay? Let us write one example of this one. Say for example, so consider this is a concave refracting surface. Okay, concave refracting surface, and this is the principal axis, and center of curvature, let us suppose it is present somewhere here. Are you able to understand? So this is the normal. So this is the normal. If I draw a straight line from the center of curvature onto the mirror, this becomes my normal. Okay. Now let us suppose object is present somewhere here. This is the position of the object. Okay. Now where is the object? Object, is it present in a rarer medium or denser medium? Denser medium. It is present inside this glass, no? So definitely this is a denser medium. But previously here, object was present in rarer medium. Now from the object, you draw a light ray. Like this. Are you able to understand? Now it is entering from denser to rarer or rarer to denser? Denser to rarer. So what happens to the speed? Speed increases, no? Are you able to understand, ma? So it should travel like this, no, ma? Okay, actually it should travel like this if there is no second medium there. But because there is second medium, what happens to the speed of light? Speed of light increases, so will it bend towards the normal or away from the normal? Away from the normal. So it starts moving like this. Are you able to understand, ma? Similarly, from here also, if you draw one more light ray, again it will bend away from the normal. So this light ray and this light ray, will they meet with each other? They will never meet with each other. So real image cannot be created in this condition. So what I do? Extend this light rays backwards. Okay, if I extend the light ray backwards, here image will be created, no? And what kind of image is this, real image or virtual image? It is a virtual image. Are you able to understand, ma? Okay, now for this condition, shall I use the first equation or second equation? Second equation. Why second equation? Because object is present in denser medium, that's all. Fine, no? And here also real image can be created, again depending upon the position of the object. Fine, that's it. So when object is present in rarer medium, this is the equation. And when object is present in denser medium, this is the equation. So what is the difference between these two conditions? Just we are interchanging mu1 and mu2 values, formula difference. Okay, come on, 240. Okay, so let us try to understand this question. So a convex refracting surface of radius of curvature 15 centimeter. So it is separating two medium of refractive indices 4/3 and 1.5. Okay. So first of all, let us draw the diagram of this one. Convex refracting surface, no? So this is a convex refracting surface. Okay. So this is separating two media. It means this is first medium and this is the second medium. Okay, ma? And what is the radius of curvature? If I complete this one into a circle, so approximately I can say this is the position of the center of curvature. And the radius of curvature, how much he gave? So this is approximately 15 centimeter. Okay. So this is first medium and this is the second, medium number 1 and medium number 2. So what is the refractive index of first medium? 4/3. So therefore mu value is 4/3. And what is the mu value of this one? Mu value is 1.5. So an object is kept in the first medium at a distance of 240 centimeter. It means object is present somewhere here. Now this is the position of the object. And what is the distance from the pole? Distance from the pole is 240 centimeter. This is the given data, no? Now the question is, object, is it present in rarer medium or denser medium? Rarer medium. How can you say it is rarer medium? Because 4/3 is less than 1.5, no? 4/3, 1.33 only. And this is 1.5. So when compared to this medium, 1.5 means this is glass. 1.33 means that is water. Okay. So this refracting surface is immersed in water. We can assume like this. Because 1.33 is the refractive index of water. Okay. So this is 1.33. So total water is surrounding this refracting surface. So whatever it may be, object is present in rarer medium. Okay. And this is the denser medium. So if object is present in the rarer medium, then which is the equation I have to use? So mu2 divided by V minus mu1 divided by U is equals to mu2 minus mu1 divided by R. This is the relation. In which condition I can use this relation? Object in rarer medium. Okay. An object is present in rarer medium. So now do the calculation. Mu2 value. Now this is mu1, this is mu2. Because already we discussed that a rarer medium should be mu1, no? And denser medium should be mu2. Clear now? So mu2 value 1.5. Image distance I don't know. Mu1 value is 4/3 or 1.33 also you can write. Object distance minus 240. Very good. Because this is the pole number. Light is traveling in this direction, but we are doing the measurement in opposite direction. So therefore minus 240 is equals to mu2 value 1.5, mu1 value 1.33 divided by radius of curvature. Radius of curvature 15, plus 15 or minus 15? Plus 15. Why plus 15? Light is entering in this direction. We are also doing the measurement in the same direction. So plus 15. So V is the only unknown quantity number. So just calculate V value. That is our answer. Fine. Come on, do the calculation. So V value you should get 270 centimeter. V value which you should get is 270 centimeter. Are you able to understand, ma? So plus 270 we got. What is meant by plus 270? Plus 270 ante? If I measure distances in this direction, it is negative. If I measure distances in this direction, it is positive. Are you able to understand, ma? So image is created on this side. Fine. So image is created on this side means, is it a real image or a virtual image? Real image. Are you able to understand? It means light enters like this and image is created somewhere here. This is the image. So definitely this one should be a real image. Okay? Real image. That's it. Fine. That is how we have to do the calculations. Come on. What is the question he is asking? So radius of a sphere of glass is 15 centimeter. So consider this is a sphere of glass sphere. Okay, ma? And this is the principal axis which is passing through the glass. So this is the center of the glass, which is also called as center of curvature. Center of the glass is center of curvature only, no? And from the center of curvature, if I draw any line, that line will become the normal. Okay? Because wherever you draw the line always touches the mirror or any glass or refracting surface at an angle of 90 degrees. That is the property of line drawing from the center of curvature. Okay? And what is its radius? Radius of curvature, it is how much more? 15 centimeter. Okay? So there is a small air bubble at a distance of 6 centimeter from the center of the sphere. It means for this total is a 15, no? Total radius is 15. So 6 centimeter means where? Somewhere here. Okay, ma? So here there is an air bubble, or let us draw in the form of a bubble. So this is a air bubble. Okay. What is the distance of air bubble, ma? Distance of air bubble, this distance is how much? 6 centimeter from the center. He is not asking from the pole. He is asking from the center. Okay. So an observer is standing here and he is looking at this bubble. Are you able to understand, ma? Observer is standing on this side on the same side as which bubble is present, and he is observing this bubble. Now the question is, where image of this bubble will be created? No, that's the question, no? How far from the surface will it appear to be if the refractive index of glass is 1.5? Its actual position is 6 centimeter from the center, but to this observer, how does it appear? How does it appear means what? Where image will be created? That's what he is asking. No, you can see image only, no? Object you can never see. You can see only image only. So image where will be created? That is the question. Okay. Now, see, first of all, this is the object, you know. This air bubble is the object. Object, is it present in rarer medium or denser medium? Object is present in denser medium. If object is present in denser medium, then what is the formula? Mu1 divided by V minus mu2 divided by U is equals to mu1 minus mu2 divided by R. This is the equation. Now, which is the mu1 and which is mu2? Mu1 is always rarer medium. Mu2 is always denser medium. That also we have studied, no? So mu1 is air only, no, here. So definitely air only. It is present in space. It means first medium is air only. Okay. So 1 divided by refractive index of air is 1 only, no, ma? So mu1 is nothing but mu air, which is equals to 1. Clear? Image distance, that's what I am supposed to find out. Okay. Mu2 value, refractive index of the glass is how much? How much he gave? Where is that 1.5? 1.5. So 1.5 divided by object distance. Now here can you say which is the pole of this glass? This becomes the pole. Are you able to understand? So object is present at how much distance? 6 only, no? No. This distance you have to take. 9. So this distance we are supposed to take, no? Are you able to understand? No? And what is this distance? This distance is 9 centimeter. Plus 9 or minus 9? Minus 9, because from the object, light is going to the observer in this direction. No? Are you able to understand? No? So light is traveling in this direction. This is the direction of light. But we are measuring distances in opposite direction. From the pole we are measuring, no? So minus 9. So therefore what I will write here? Okay, ma? So image distance is plus 9 or minus 9? So it is minus 9. Okay. Mu1 value 1. Mu2 value 1.5 divided by radius of curvature. Radius of curvature is how much? Radius of curvature plus 15 or minus 15? Minus 15, because again every distance I should measure from pole only. But light is traveling in opposite direction. Clear number? So therefore minus 15. So calculate V value. That is our answer. Okay. So therefore if I calculate V value, then it is minus 7.5. Minus 7.5 centimeter. Okay. Now can you say what is meant by minus here? Minus means what? Minus means it means I am measuring distances in this direction. No? If I measure distance, if I measure distances in positive direction, then I should have got a positive value. Okay, but negative value means what? Image is created somewhere inside the mirror, inside this glass sphere only. Okay, let us see that also. See, but this is the normal, no? This is the normal. So light traveling from the object and falling here. Okay. Now light is entering from which medium to which medium? Denser medium to rarer medium. So what happens to the speed of light? Increases. What happens to the wavelength of light? Wavelength of light increases. What happens to the frequency of light? Frequency of the light doesn't change. What happens to the color of light? Color also doesn't change because frequency is not changing. No? Are you able to understand more? So therefore, will it bend towards the normal or away from the normal? Away from the normal. So it starts moving like this. Okay. Now if you extend this one backwards, so image is created somewhere here. Satisfied now? Clear now? Object distance is 9. Image distance is only 7.5. Okay. So this is how you can create image in the case of refracting surfaces, convex or concave. 15 centimeter is placed in water of refractive index 4/3. Clear? So let us draw a flask first of all. Okay. So this is an empty flask. Nothing is present in this flask and is placed in water. So it is completely immersed in water. Empty flask is immersed. It doesn't mean that water is present inside this one. Water is not present inside it. Okay. So this is an empty flask. Fine. And where is the observer? Observer is present on the inside of this flask and he is observing. Clear? So let us draw the principal axis. What shall we take as the principal axis? So let this one be the principal axis. Okay. And this is the center of curvature, no? So from the center of curvature, if I draw any line, that line becomes the norm. Okay. Then a parallel beam of light strikes the flask. Okay. Parallel light beam means what? So consider this is another normal, first normal and second normal. Clear now? So light ray coming parallel to the principal axis like this. Okay. And here also light ray coming parallel to the principal axis like this. Are you able to understand? Now light will enter, light is entering from which medium to which medium? Light is entering from denser medium to rarer medium. Here air is present, no? Inside the flask which material will be present? Air will be present. Air is a rarer medium. But light is coming from water. Water is a denser medium. Are you able to understand? So therefore what happens to the speed of light? Speed of light increases. When speed of light increases, it bends away from the normal. So actually light should travel in this direction, no? Light should travel like this. Okay. But it bends away from the normal normal. So therefore it bends like this. So here also it bends like this. Are you able to understand? So if they are not meeting with each other, no? This light ray and this light ray, they will never meet with each other because they are diverging. They are not converging, no? If converging, real light rays, real image will be created. But because they are diverging, if you extend them backwards, so image will be created somewhere here. So this is the formation of the image. Are you able to understand? So this distance I am supposed to calculate. This is the pole of the mirror. Pole of this flask. Fine now. Now is this a convex surface or a concave surface? Convex surface. If I look from here, this is a convex surface. If I look from here, this is a concave surface. Are you able to understand? Whether it is convex or concave, we have only one formula. No? Convex or concave, for both of them we use the same formula, so no problem. So therefore object is present where? Rarer medium or denser medium? Object in denser medium. It is present in water, no? Light is coming from water. Okay. So therefore what is the equation? So mu1 by v minus mu2 divided by u is equals to mu1 minus mu2 divided by r. That is our equation. Okay. Mu1 is always rarer medium, no? What is the refractive index of air? 1. V, object distance, image distance, I don't know. Mu2, refractive index of water. Refractive index of water 4/3. Okay. Next u means what? Image, object distance. Where is the object? Object should have been at infinity. Then only light rays can come parallel to the principal axis. Are you able to understand me? So therefore object distance is undefined, infinite. Okay. So this is equals to 1 minus 4/3 divided by radius of curvature. Radius of curvature how much? 15 centimeter. Diameter is 15 centimeter number. So radius of curvature will be 7.5 only. Plus 7.5 or minus 7.5. So this is the pole, no? Light is coming from this direction. Radius of curvature also I will measure in the same direction. So it is positive. Okay. So plus 7.5. Are you able to understand? Now just to do this calculation, find out V value. That is my required answer. Okay. So if I calculate V value, what I will get? minus 22.5. Okay, ma? So minus 22.5 centimeter. So minus is satisfied, no? See, ma. So this is the pole. Light is coming in this direction, but I am moving in opposite direction. It means image is created somewhere here. Okay, ma? So definitely negative distance. So minus 22.5 centimeter. Fine. That's it. Okay, ma? So how magicians use this technique is that now light is coming from infinity, no? Image is created here. So they will place the object such that image is created at infinity. Object position ekkada place chestarante image will be created at infinity. Okay, ma? Then